Hey everyone, my name is Kanaya Gupta. Welcome to my YouTube channel. Today I am going to discuss count triplets hacker rank problem. But before moving ahead, make sure you are subscribed to my YouTube channel and click the bell icon so that you don't miss any update. Let's start. In this problem, you are given an array and you need to find number of triplets of indices I, j and k such that the elements at those indices are in geometric progression. For a given common ratio R and I is less than j is less than k. For example, we have this array 1, 4, 16 and 64, and if R equals to 4, this is the common ratio, then we have 1, 4, 16, basically 1, 4 and 16, and 4, 16, 64, 4, 16, 64. So these are two triplets which can be formed from this array, and all element or item having a common ratio of given R. So you can see the common ratio of this between this and this is 4, and here also it is 4. And these are the indices basically 0, 1, 2. So this is 0, 1 and 2. So 0, 1, 2, 1, 2, 3, 1, 2, 3. So this is 1, 2, 3. So we don't need to bother about the indices. Here we are looking for how many triplets we can form. So we can form only two triplets. One is this, one is this. So you need to find out from the given array how many triplet you can form such that the triplet is having common ratio of R, and this property also should be satisfied where I is less than j is less than k. So this is what we have to find out. So complete the count triplet function in the editor below. It should return the number of triplet forming a geometric progression for a given R as an integer. So count triplet has the following parameters: array, an array of integers, R, and integers, the common ratio. So the input format will be something like this. The first line contains two space separated integers, n and R, the size of array and the common ratio. So n is the size of array and R is the common ratio. The next line contains n space separated integers. So these are the guys. Please look at here. This is a constraint. This is a very crucial information which will help you what kind of data type and storage you should use while doing a programming. So you should not ignore this. This is here just because of some reason. So just look here. N can be vary between 1 to 10 raised to power 5, and R can vary from 1 to 10 raised to power 9. An element of the array can vary from 1 to 10 raised to power 9. So because all the things in a geometric progression, so we know in geometric progression it should work something like this. Suppose first term is A, then the next will be AR, and the next will be AR square, something like that, right? So this is the R, guys. So when you talk about the third term, so it will go to the R square. So basically 10 raised to power 18. And then you have to multiply the array element also, which is A, right? So the number is going to be very, very huge or big. So you have to make sure you are dealing this kind of big input. So you can't use int data type here. So you have to use something bigger, maybe long or big integer or something like that. Because I have seen a lot of people face this issue. And when they code their algorithm, even the algorithm is correct, your program will not pass all the test cases. Why? Because you are using data type something integer and all, which is not capable to store this much big value. So you should always make sure based on the constraint you should choose your data type. So please do not ignore the constraint whenever you are solving any kind of problem. Look at it once, what kind of constraint is given, and based on that decide what kind of data type you should use in your program, data type and data structure and all, right? So now you know that the result is going to be very, very big. So definitely we are not going to use integer here. So let's move ahead. And the output format is count of the triplet that form a geometric progression. Let's see this example, guys. So this is a 4, which is the number of element present in the array, and this is 2, which is R. So this is n, This is R, and these are the array element. So how many triplet you can form? You can form 1, 2 and 4. Now you see the common ratio between these triplet is 2, and the indices constraint is also satisfying. I is less than j is less than k. So this is a one triplet, guys. And the second one can be I, j, k. So we have two triplets, right? Which is satisfying this condition. So the answer is 2. Let's move on to the second example, guys. So this is one more example, guys, where this is n. The number of elements present in the array is 6. So you can see 1, 2, 3, 4, 5, 6. We have 6 elements. And this is the R, which is a common ratio. So you have to find out the number of triplet can be formed by using this array with a common ratio of R, which is 3. So one triplet can be this, right? So one triplet can be this because we have a common ratio of 3. The one triplet can be this, right? Another triplet can be this. So far we have 4, right? So any other triplet we can form? Yes, we can form 9, 27 and 81. And another will be this 9, 27 and 81, right? So overall, if you count, we have 6. So we can form 6 triplet, and indices of this triplet is mentioned over here. But you don't need to focus on the indices, guys, because at the end you need to return only the count. So you have 1, 2, 3, 4, 5, 6. So you need to return 6 as your answer, because at max 6 triplet you can form by using this array. So in the similar way, guys, you can look into the second example that I will leave it as an exercise for you. So let's build the logic around it. So here I have taken a sample input, guys. So in that we have n equals to 8 and r equals to 3. So these are the 8 elements which is present in the array, and we have to find out how many triplet we can form with common ratio of 3, right, from this array. Guys, as mentioned in the problem statement, the triplet forms a geometric progression. So can we assume the element of the triplet should be something like this? First term will be a, and second term will be ar, the third term will be ar square. So these are the term which follows the geometric progression, or sometimes people use this a by r, a and ar. So you can see the common ratio between adjacent two term is r, right? So either you can choose this or this, which doesn't matter, guys, but these terms are in GP. So a triplet must satisfy this condition, because in a problem statement it's clearly mentioned the triplets are in GP. So one algorithm is pretty much simple, guys. So we can apply 3 nested loop where we can treat each and individual element as a and r is already given. So we can calculate these two terms also, and we can check whether these terms exist inside the array or not. If it exists, it can be counted as a valid triplet, but we have to make sure it also follows the condition where I is less than j is less than k. By using that, we can also solve this problem, but due to 3 nested loop, so the complexity will be n cube, which is too much. But we have to see if there is any optimized way to solve this question. So let's see how we can optimize this solution. Let's assume this is the array, which is 1, 3, 3, 9, 9, 9, 27 and 81. So let's suppose while processing this array, I choose every element as a A. So AR and AR square will also should be in this array somewhere, but AR should come first before the AR square because of this constraint. Then only it will form a valid pair. So it will be very difficult for me to track the indices of AR and AR square. So what I can do, instead of using A or using this kind of structure, I'll use this. So whenever I process this array, I'll treat this is A and if I divide A by R, basically the common ratio, then I'll get a element which is on the left side. And if I multiply A with R, I'll get an element which is on right side. So if I am on a mid, then it will be easy for me. If something is on my left side, so it means definitely it will be less than, or basically treat this is as a J. If something is on my left side exists, it means its index will be lesser than this. And if something is on my right side, the index will be greater than this. So in that case, I don't need to bother about the indices part. So every time when we are processing this array, every element will treat as a, and we'll see whether A by R exists on the left hand side or not. If A by R exists on the left hand side, then we check whether A into R exists on the right hand side or not. If these three conditions, or basically these three elements exist inside the array, it means we found a valid pair which is capable of forming a triplet with the given condition. So we can count as a valid triplet. So let's use the same thing. So let's take the same example. So when we process this complete array, guys, right? When we use every element as a, so basically if this 3 is suppose forming a 4 valid pair of triplet, and if we replace this 3 with this 3, then this will also form the similar number of pair. So we are not going to calculate the same thing again and again if the element is occurring more than once. By doing this, we are trying to save our time. If suppose the same element is about 10 times, so same thing you are going to calculate 10 times, which is not the optimal approach. So what we are going to do, we'll calculate only for once and we'll multiply based on the frequency. So what we do, for that we'll use a map here and to maintain the frequency. Let's take, we know we have A by R, A and AR. So there's one map which is called right map, and that will calculate the frequency of each and every element. Guys, those who don't have a map in their programming language, either they can implement it or they can use the array. So both will work. So now this is the frequency, guys. I am just maintaining the frequency count. So this is the right map. Why it is the right map, guys? Because initially we will start from here, and when we start, everything is on right hand side over. So this is the right map which will maintain the frequency of each element. There is one more map, guys, which is left. I'll show you what I will do with the left map, but currently it's empty because when we start, the left hand side nothing is there, so that's why it's empty. So let's process this array element and treat each individual element as a and look for A by R. So when you process this element, suppose you are processing this one, so you need to decrement the count of frequency of 1 because now this is not a part of a right map. Initially we have not started, that's why it's a part of right map. But when we have taken into a processing as a, so this will not be a part of map. So just reduce the frequency. So I'm reducing it to 0. And look how many A by R exist on the left hand side. For checking this left hand side, we have a left map. So because nothing is there, so there's a 0 occurrence of A by R. So we should not calculate AR now because this cannot be a valid pair because this element is missing. So now we'll process this. So let me remove this. So I'm processing this 3. So when I'm processing this 3, but before that, what is on the left hand side, guys? 1. So a left map will have a, when I'm taking this as a, so this is on the left hand side. So let me increase the frequency of left map. So for one element we have 1, right? And for the right hand side, we have to remove the frequency of 3 also because now 3 is A, which is a processing element. So this right map, basically this is the right map, guys. And now this is the left map. So left map we have frequency of 1 to 1, and this map of frequency is already there, but we have to remove the frequency of 3 because previously it was 2. But now the right map size got reduced, so we have to remove the frequency of 2 to 1. So I'm changing it to 1. Why I'm doing this, guys? Because whenever I'm processing any element, it will always be easy for me to look into the left map. So I know if I'm looking into the left map, that will always be having the less index from the A. And if I'm looking on the right map, that will always be having a greater index from J. Because we know the concept of I, J and K, right? I should be less than J and J should be less than K. So if you do or divide this problem statement to three different parts, mid, left and right, so you'll never mess up with the indices. So you don't need to check explicitly for the indices whether you are following that I is less than J and K. Because now you have divided into three parts, you know if something exists on the left hand side, if something exists on the right hand side, it means we are following that I, J and K constraint, right? So now this is the one we are processing. So how many A by R element are there on the left hand side? 1. And how many AR element exist on the right hand side? AR is nothing, just the multiplication of A and R. A is this 3 and R is 3. So 9. How many 9s are there? 3. Guys, why we have used map? Because we want to know the frequency of 9. And we know if you want to know the frequency, basically which is a lookup operation, hash map is the best, basically the map, because it has a O1 complexity or constant time complexity for lookup. So if you look for the 9, how many frequencies are there? 3. So you know left hand side A by R is having 1 and right hand side 9 is having 3 frequencies. So 1 into 3. Guys, I'm using the same formula, M into N. So overall you can form 3 pair, right? Now I'll move this cursor here. So let's do it. So this time processing element is this, and left will be this and right will be this. So left map will increment the frequency of 3. So now 3 is not there, so we will take the 3 and increment the frequency. And the similar case in the left hand, in the right hand map, basically right map, we will reduce the frequency of 3, which will be from 1 to 0, because we don't have 3 now. And now this 3 is a processing element. So when this 3 is a processing element, how many A by R, right, are there on the left hand side? So A by R is nothing, it's just a 1 and 2. And how many AR are there? Which is 9 frequency, which is 3. So this is also a 3. So far this 3 plus this 3. So overall 6 combination can be formed. Next, move to the 9 here, guys. So I'm just removing this. So now the element will be 9. So this is our left map and this is our right map. So based on that, just we need to adjust this also, guys. If this is the left map, so 3 frequency we are going to increase. So I have made it as a 2. And on the right hand side, I am going to reduce this frequency to. So if you're processing 9, treating 9 as a A, so how many A by R exist on the left hand side? A by R means 9 divided by R, 3. So 3. So how many 3 exist on this? Now this map will help, guys. How many 3 exist? 2. How you will come to know? Because you will do lookup operation on this. So how many frequencies are there? 2. 2 AR exist on the left map. And how many AR exist on the right hand side? AR is 27. So how many 27 are there? We'll look into this map. 1. So 2 into 1, which is 2. So overall we have 3 plus 3 plus 2. So far 8 combination. So now move this cursor to here. So this time now this is our left map and this is our right map. So based on that we have to update this, guys. So now in left map 9 is also there. So this will be 9 with frequency 1. And here we need to reduce the frequency of 9. So here only 1 frequency. If this is the processing element, so how many A by R exist? 2. So count will be fetched from this left map. 2 into how many AR exist here? 27. So frequency of 27 is 1, which is 2. So we'll add this. So overall this, right? So in the similar way, next element will process to this 9. So this is the 9, guys. And this is our left map. This is right map. So left map, I am going to increase the 9 frequency. This time this will be 2. And right hand side, we are going to reduce the frequency of this 9. So it will be 0 now. So how many A by R are there in the left map? So frequency of 3 will be 2. And how many AR exist here? 27. So frequency of 27 will be 1. So we'll add this also. So right, so we have processed till here. Now we'll move to 27. So now 27 is the processing element, guys. So this will act as a left map and this will be as a right map. So when this will act as a left map, so how many elements are there? 1 with 1 count, 3 with 2 count, and 9 with 3 count. So 9 count will be 3, 3 count will be 2, and on right hand side we'll reduce the 27 count, so it will become 0. So we have only this element in the right map. So how many A by R is there? So 27 divided by 3, which is 9. So how many 9 are there in the left map? So we'll go to this left map and see the frequency of 9 is 3. Into how many AR? Basically 81 are there in the right map. So in 81 frequency is 1. So it's totally 3. So we have 3 combination, guys, because we can use 9, 27, 81, this 9, 27, 81 and this 9, 27, 81, right? So now let's move on to the last element. So if the processing element is 81, so this will come in a left map and this will come in a right map. Basically this is nothing. So if 27 is a part of left map, so we are going to enter a 27 here with a frequency 1 and we are going to reduce the frequency of 81 from here because in right map it does not exist. So the frequency of 81 will be 0 now. So how many A by R exist here? 81 divided by 3, which is 27. So the frequency of 27 in our left map is 1 into the frequency of 81 into 3, whatever it is, because it doesn't exist, so it will be 0, guys, because that will not exist in this map, right? Basically the 243 which does not exist. So what is the frequency of that 243? It will be 0. So 1 into 0, so it will come as a 0 plus. So now if you do this total, you will come to know the number of triplet which can be formed. So let's do a quick total. 3 plus 3, 6 plus 2, 8 plus 2, 10 plus 2, 12 plus 3, 15. So the result, the total will be 15, which is our answer. I hope, guys, you have got the idea how we have solved this question. We have processed this array by taking each element as a and taking two different maps. One is a left map, one is a right map. Why we are doing this, guys? Just because we do not want to mess up with the indices. We always have to make sure I should be less than j and j should be less than k. So basically, if we are taking an element which is in the form of GP, so we always have to make sure forming a GP and we are treating A as a j, then it should always be greater than I, and this is always should be lesser than k. So we are treating as a middle element and one element exists on left hand side and one element exists on the right hand side, then we are good. I hope, guys, you've got the idea. Now let's see the algorithm in action, guys. So this is the method, guys, count triplet. So in that we are accepting two parameters. One is a list and second is a common ratio, which is R. So as we discussed, I have taken two maps here. One is a left map and second is a right map. Initially, we have filled up the right map values. So I'm looping through the complete list, guys, and storing frequency of each and individual element inside this right map. So which you can do in your own way, guys, whatever the programming language you are using. But what it does, if that element exists, then use the value of frequency of that particular element and increment by 1, else it will be 0. So get_default means default value of that particular key will be 0 if it is not able to find that element into the map. Okay, so basically we are maintaining the frequency count, guys, nothing else. If you are not able to get it, it's okay, you can implement in your own way, but here just we are calculating the frequency of count. Just to get the similarity, let me show you what you will get after processing this right map. So this is what you are going to get, guys. So this is the right map, guys, which you are going to get after it. So initially you have 1 1 3 2 9 3, right? So the right map we have filled it. So this is what you are going to get. So now focus on the pure logic, guys. Syntax can be vary based on the language, but algorithm will not. So this logic will just maintain that map. Now I've taken one variable count, which is equals to 0, because at the end I am going to return this count. How many number of triplet can be formed, right? So now I'm processing each and individual element, guys. So this is the loop for that. And I'm taking that element from the list and calling as a midterm. Basically the A, guys. Midterm is like in mid, whatever the terms come. So if you're using A by R, A and AR, so midterm will be A. Here I am using C1 and C3. At the end we are calculating that. So this is what C1 and C3 are doing here. But initially, this is the right map. What we are doing, whenever we find any element, we are reducing the frequency from the right map. So this logic will just reduce the frequency, guys. You can see -1. So if that element is present in the right map, we are reducing, because now that element will work as a midterm. So this is a condition, guys, where we are checking in left map whether we have midterm by R. Basically A by R exists or not. And along with that, guys, we have to use this modulo operator also. Why? Because midterm by R, this division operator will not give you a guarantee that midterm is completely divisible by R. Let me show you with the example. Suppose you have series something like this. So if you use this 3 as a and divide by R, so A by R will be 1. And if you use this 4 as a, 4 by 3 will be also be equals to 1, because it's an integer division, right? Which is wrong. So that is the reason you are going to add this condition, which will confirm if modulo is not a 0, it means it's not completely divisible, because we are looking A by R, which is completely divisible. So this cannot be a part of the valid triplet. So that is the reason we have added this condition. I hope you got it, guys. So when we are checking for the A by R, we also have to look if this is true or not. If it is true, it means it exists in the left map. If it exists, then we are getting the count of this term. So we are storing that count into a C1. And from the right hand side, also we are getting the count of A into R, basically midterm into R. If midterm into R or A into R exists in the right map, we are getting the count from this, which is C3. And now we have a count from both the side, from C1 and from C3. Then we are going to multiply that. If you remember, guys, let me just show you. So basically, guys, this is a C1 and this is a C3. Let me note it down also here, just for your reference. So this is we are C1 and this is C3, guys. So from the left map, whatever is coming, I am using as a C1. From the right map, whatever frequency is coming, I am using as a C3. So once you know that, you are multiplying, and which will store into a count. Before moving to the next iteration, you know now that particular element which was working as a here, that will go as a part of left map. So in the left map, we are incrementing the frequency of that particular element. Now for the next iteration, we are doing the same thing, reducing the frequency from the right map, calculating the C1 into C3, and incrementing the frequency in the left map. Now once we have done with the processing, at the end, count will maintain the number of triplets which can be formed from the given array, and we are returning that count. Let's try to run this code, guys, on a HackerRank platform. So let me replace this code. Let's run this code. So sample test case got passed. Now I am submitting this code. So you can see, guys, all test case got passed. I hope, guys, you have enjoyed it. And if you find this tutorial helpful, please like, comment, share, and subscribe to my YouTube channel. Thanks for watching, guys.